All right, we're recording. So, first, just a couple of words, organizational stuff. Um, I understand that it can be very hard to get something that I'm explaining quite fast, just don't get discouraged just yet, okay? So hold on, and by the end of the week, I promise that you will feel much better. That's the first thing. And today's presentation, I think it's gonna pass easier because yesterday we had to recall so many, formulas and concepts. So today we talk about functions, which is much sweeter in general. I want to share with you some resources online that you can use. So I'm just gonna type it here in the conversation. So the first one, you most likely already know it. It's Khan Academy. They really do great videos. And whatever you don't understand, before trying to, go to textbooks or go over and over again with my notes or with the videos, try to just Google it and find the Khan Academy video on that part. Like, for example, you get confused on how to deal with the exponents. I don't know, like, why would x to the power of 2 times x to the power of 3 will be x to the power of 5? Why? You go there and just do multiplication of exponents. And most likely, you're gonna find something nice. And it's also nice to change the way of learning. So my style is one, it may be suitable for you, may be absolutely awful for you. So then you can check how other people explain, and maybe that's gonna help you. So that's one. And another one is a YouTube channel that I love. Helped me a lot, and they're the same. Go through the videos, it goes from the simplest to the most difficult. So that's just, some other places where you can search for information. Then I sent yesterday the textbooks to Satchel, one of your old classmates. For example, the first reference that I can give about exponents and logarithms, it's like the first page of Dowling textbook. Page 1, I can say, this is for exponents and logs. And you will see that there is on the second or third page explanation of how to solve the quadratic equation that I showed you yesterday with the Vieta's formulas. You can find a formula of a discriminant. Not super crucial for now for you, but nice to know. Sometimes you just need to solve something real quick for a micro question, and this is something that the tutors will suppose that you know by default. So it's good time to revise. And the first part of Dowling textbook is basic concepts that for sure you will know. I mean, for sure you'll have to know. Okay, so that's the best source for now. Another textbook that is, I don't remember the name of the author, but I refer to it as CW. It's good, but not for the very beginning. So if you feel confident with, everything that we talked about yesterday, you should go on using that textbook. But even for derivatives and functions, I prefer Dowling. Yeah, it is Chang and the other guy, W. So I prefer Dowling textbook because for me it's written in an easier language. That's just, to give you guides for textbook use. And the last one, the Floyd textbook, is statistics. So don't touch it yet. There is nothing that we're talking about this week for sure. I told you yesterday that it's nice and we're gonna try to organize office hours. I think it's better to do it online as well, because otherwise it can be unfair for someone who is not in Paris. So we'll see about that. And I really received a bunch of questions yesterday, like a bunch. So if I didn't get back to your email, just hold on, I will. So I was thinking that actually organizing an extra session will be okay. But what I really don't want you to do, what I wish that you don't do, is just, okay, you don't understand the concept, and without looking anywhere, you just are like, okay, explain to me again. So certainly, I will explain to you everything again with great pleasure. But I really like you to first simply Google it. Sometimes you find the great videos in other YouTube channels, not the ones that I mentioned. Then check the textbook, and then you'll see miracles. After you do all that, you still don't understand? Okay, perfect. Here we can talk. So thank you in advance for that. And today we start with solving our homework. So I'm going to first share just the notebook, so just the whiteboard. Up. Okay, so here you are all. Up, up, up. Okay, cool. So let's start with the very first sum. So now I'm gonna go step by step, but for real. So if you find it boring, go get a cup of tea or something else. Okay, so here we go. The first one was the sum. And the sum that we had was with J. And I deliberately put you another letter so you get confused. Doesn't matter at all. As I told you, it can be K, it can be J, it can be even N. And then we had a fraction of -1 to the power of J. Not capital J, just normal J. And then here we had J plus 1 times J plus 3. Okay, so that is equal to what? Here, as you can see, the number of terms is very little. We have 2 plus 1 terms, 3 terms. How do we know actually? Because last time I didn't explain that in the sum of from 0 to n, why do we have n plus 1? Well, you should think of it like that. From 0 to 3, how many numbers you have? 0, 1, 2, 3, you have 4 numbers. So it is the final minus plus 1. So the way we calculate the sum, the way we calculate the number of terms, like, okay, that's a good one. For example, let's take I that goes from 6 to 14. It also can happen because, well, in all of my examples, it was something like from 0 to n, but it can happen that we take a sum of from like the middle of the line. Okay, how many terms of I? Not I. Yes, I. 9 terms. Okay, how did we calculate that? there is a formula which is weird, right? There should not be a formula because you can just calculate 6 and but the formula says that 14 minus 6 plus 1. Why do we have to do plus 1? Because the 6, so the very first term also counts. If you don't want to have memorize the formula, so like for example what is the formula? So the upper limit minus the lower limit plus 1. It is always plus 1 because we have to account for this first term. And if you don't want to memorize the formula, you should always keep in mind the example from 0 to 3. How many do I have? 4. From 1 to 3, how many do I have? 3. 1, 2, 3, right? So you do, if you want to follow the formula, you do 3 minus 1 plus 1 and you get 3. Okay, sweet. I think now that should be very clear. Then, here, I'm gonna write it like that. Oh, in the PDF that I sent you, I've tried to organize, my notes, writing some titles. So, okay, here, that's what we're talking about. I hope it's okay. If it still looks very messy, let me know. You can spend some more time working on that. Okay, we have here 3 terms, and we can write them down, right? So, the first term, we substitute j by 0 because that's the first value that j is taking. If we substitute j by 0, we already know that any number to the power of 0 is 1. Perfect. Then it can be negative, positive, it can be a fraction, whatever to the power of 0 is 1. Then here, what do we have? We substitute this j with 0 and this j with 0, and we get something like 1 times 3. Okay. Then, that's the first term where j takes the value of 0. The second term, j will take the value of 1. So we're going to get another fraction. And here, what we have? Minus 1 to the power of 1. That's minus 1. So don't lose the minus. And here we have 1 plus 1 times 1 plus 3. 2 times 4. Okay. Then what we have, the last term, minus 1 squared, right? Minus 1 to the power of 2 because that's the last value that j takes. It's 2. Minus 1 to the power of 2 is 1. So the positive exponents, they make everything the positive exponents. The even exponents, they make everything positive. So minus 1 squared, minus 1 times minus 1, minus times minus is plus. Okay, I warned you. I'm really going step by step. So here, we're gonna have 3 times 5 because we substitute j by 2 here and by 2 here. Okay, from this point onwards, you know how to calculate, I hope. If you don't know that, I'm not going to explain. Just go through high school textbooks. And here, we get the result, supposed to be 11 over 40. So if you didn't get it due to calculation or arithmetics mistake, is fine. So everything I want you to know is how to write the extension of that. Then calculations, well, you'll have to obviously calculate stuff. And for micro, for example, they don't allow calculators, but it doesn't require any crazy calculations. But the most important is to know how to write it. And even, for example, in micro, you made an arithmetic mistake, the professor will not judge you super harsh. And I make arithmetic mistakes all the time. For example, the first time I did this, 2 2 times 4, I calculated as 6, and then I got a pretty answer, but a wrong one. Alright, so that was the first one. Then the second one. Oh, let's go here. The second one was 1 plus 3 plus 3 to the power of 2 plus 3 to the power of 3. Then it was plus, plus, and the last term of this series is 3 to the power of 81. So I now figured how to fix this. Look how beautiful. Okay, so we see here that what changes is the power. So it's the exponent, right? So we see, so the first value of the exponent is 0 because we have 1. So any number to the power of 0 is 1. Then we have that 3 gets the exponent of 1 for this term. Then it is 3 squared, then it is 3 cubed, then it is, did I write it like that? Did I write 3 to the power of 81? Just do me a quick yes in the conversation. Okay. Yeah, now I realize that what I actually wanted is to just write 81. So you realize that it's 3 to the power of 4. But yeah, well, doesn't matter. Let's solve this one. So we see that the powers go from 0 to 81. Well, we write this sum where we have I that goes from 0 to 81. Great. Of 3 to the power of I. I is something that is changing. We have a sum. Here you go. Okay, cool. That was the second one. Then the third one is something interesting. A to the power of 6 plus 6. A to the power of 5b plus 15. Ooh. A to the power of 4. B to the power of 2 plus, you all know what is plus, and the last one is b to the power of 6. So this must have reminded you a little bit of the extension of a plus b to the power of 4 that I did, and actually I used again different letters. It really doesn't matter if I have in a formula x plus y to the power of 4 or x plus a plus b to the power of n. So I don't know exactly which power, but it's some power, right? To write it in general. Doesn't matter. So the idea is always the same. It is the Newton's binomial. So how do I know it? I know it because first of all, I can see that the powers of A decreasing by 1 every time. I see that the powers of B increasing by 1 every time. What else do I see? I see that I have coefficients appearing. So it's not the exact same example as we had during the class where we had no coefficients. It is actually something with the coefficients. So I can say that this will be equal to the sum of I from 0 to 6 of see, I learned how to use that. 6 a to the power of 6 minus I, b to the power of I. So why am I so sure that these coefficients, that then we have 20, then again 15, then again 6, are this stuff? Well, you know how to calculate this stuff, and we can just take a couple of examples so you know, for sure understand what's the idea here. The letters again can be different. What matters is that there is a number on top, number on the bottom, or letter on top, letter on the bottom. So that's how we deal with that. We go ahead, do the fraction, and here we're gonna always have the letter that is on top, factorial, or the number. And here we're gonna always have this second thing, factorial, times 6 minus 1 I factorial. Okay, and here, just if you test it with I taking the value of 0, I taking the value of 1, 2, 3, 4, 5, 6, you'll see that it comes to the same 1, 6, 15. So just 1, okay? We're gonna take. So let's take 6 over 2. It's equal to, again, I'm gonna right now write a product, just product, and then I'm gonna put times. 1, 2, 3, 4, 5, 6 here. So what I mean is that these are multiplied by each other right now. I just don't want to put times. 1, 2, because it is 2 factorial. And then I have to multiply it by 6 minus 2 according to this also formula. So it will be 4 factorial. So it's 1, 2, 3, 4. Okay, now we look at this and we see that we can actually, you know, simplify 1, 2, 1, 2, simplify 3, 4, 3, 4, and we end up with something like on top 5 times 6, and on the bottom 1, 2, 3, 4, 2. And that is equal to 15. So that was this coefficient. And there is this nice property about factorials and, well, these combinations, is that this will be equal to 6, choose 4. Okay, so you can understand and then figure out why, because here what we have is this subtraction. So if it is 2, then here we'll have 2, 6 minus 2, which is 4. The other way around, it will be here 4, and then 6 minus 4, 2. So it will give you the same result. Okay, so this formula, again, nobody is going to ask you at the exam, please use the binomial theorem formula. It was just to show you, first of all, for you to get back used to fractions, get back used to factorials as they are. Just know that 6 factorials, 1 times 2 times 3, blah, blah, blah. And then to have some idea of the modeling, because what you are supposed to do with the sum operator here is to model this, right? So write it with, in this case, with an operator. Then you will have to model something with functions. So economics is anyway all about modeling. So that's what I wanted to show you. But don't get scared if you are like, oh, I don't understand, I'm not so sure if I can learn it or you know, use it. It's okay. For now, it's okay. Okay, then let's go to the exponents. First, I gave you an example of, well, you know it, right? You all have it in front of your eyes. It was 1 over 4 to the power of 9x minus 5 equals 32 to the power of x plus 8. As last time, I explained to you what we need. We need the same base, so then we are able to just say that the power is equal to the power. And here, we were supposed to get to the base of 2, because that's first of all the smallest, and second of all the only common base for the both parts. So 1 over 4 is, that's worth noting, 1 over 4 is equal to 2 to the power of, okay, type it in the chat. It's time for you to type something. Cool. Okay, for some reason you don't know where the -2 came from. The first pages of Duolingo are what you need. 4 is 2 squared, and since 4 is in the denominator, the power is negative. Okay, so we fix that. Then the second part, 32, that's very simple. That is 2 to the power of 5. Okay, perfect. Great, so what we end up with is something like 2 to the power of -2, and then again to the power of what we had, 9x minus 5. Right? So that was already the power. We should not lose it. So what we did, we just changed the 1 over 4, made it look like 2 to the power of -2. But the other exponent stayed there. And then here what we have is 2 to the power of 5 instead of 32. And again, all that to the power of x plus, which no, I don't want that. To the power of x plus 8. Okay. Now we're gonna do a little tiny manipulation. So you know that if something is already in the power but again to the power, what we have to do is multiply the exponents. So here we end up with 2 to the power of minus 18 plus 10. Because I just multiplied -2 by 9x minus 5. X plus 10. And here we ended up with 2 to the power of 5x plus 40, right? 5x plus 40. Okay, so from here it's clear. We just write a new equation, minus 18x plus 10 is equal to 5x plus 40, and the x is equal to minus, very ugly, minus 30 over 23. Again, the arithmetics is not something that you should really focus on right now. Just understand the first steps and you're gonna be good. Cool. So that was the first one. Then the second one was easier in terms of you didn't have to calculate much. So we had two fractions, 1, 3, and this was to the power of x. Okay, the whole thing was to the power of x, right? So I should do this. Okay, I'm gonna do like this, okay? You understand. Oh, it works. Charm. X, and then that was equal to 1 over 2 x. And here you were supposed to tell me, well, we have different bases and the same exponent. So it can only happen in one case. It's like 3 to the power of x is equal to 2 to the power of x. Well, whichever powers we try to come up with, it doesn't work, except for one case. And what is this case? Tell me right now what's x equal to. There is no other way for it to work. It has to be 0. Perfect. Next one, where I'm gonna show you the Vieta's formula. Again, because it was easier to do Vieta's formula. But whichever way you do it is okay. So the thing was x squared. I'm gonna add square just in a second. Minus 7x plus 10. So, oppa. And all that was equal to 1. So again, what we want to have is the same basis, right? So here we have 2. On the right side, we want to have 2 as well. So to have 2 on the right side, we just have to rewrite the whole thing. And instead of 1, we write 2 to the power of 0. Because that's how we get 1. So after all, x squared minus 7x plus 10 is supposed to be equal to 0, right? So here is where you can train Vieta's formulas. If you don't use them and they seem very hostile to you, it's okay. You can solve the quadratic equation whichever way you want. But I really like them, so that's why I'm advertising so much. We have 2 solutions for this equation. The sum of the solutions will be equal to, type in the chat, okay, we have one person who likes the Vieta's formula. Yeah, 7, because if you recall the formula way I suggested it with the coefficients b and c, the sum was minus b. So here we have our b, like the coefficient with the x negative, we do minus minus 7, we get 7. And then the product of these things is equal to, also type please, if you don't mind. Yeah, 10. Okay. Look, it's simple. You have 2 numbers that give 10 as a product and the sum is 7. Obviously, it's 2 and 5. So you don't have to go through the discriminant. You don't have to try to, create a product. It's just as simple as that. And you get your x equals 2 or x equals 5. Okay, so how useful is this Vieta's formulas and how often you'll see the quadratic equations that you'll have to solve? Not very often. So it's not something that is really like to learn by heart, but you will have to solve them, and it's nice to, have it automatically happening for you already. So that's why I'm giving more and more examples like that. Okay, so the last one where you cannot use the formula and you had to use the discriminant or whichever way you prefer solving them. You have it in front of you, 2 to the power of x squared times 1 over 2 to the power of 1/4 x equals to 8 to the power of 1 over 4. Are we allowed to use the... Obviously, yes, you are allowed. Like, you're not going to be asked to solve it by Vieta's theorem. You're going to be asked to solve it. And whichever way you prefer, go for it. And so here, I find it very simple. Obviously, when you have the nice numbers, right? You could have 11 here and the whole thing would just screw. But given you want to go the PQ formula, you want to discriminate, whatever. Just this is one of the methods that I advertise. The other methods can be also found in Duolingo. Okay, so let's move to the last with 2 to the powers. So here what I wanted you to do again is to get on the left side and on the right side of this thing something with a base 2, because base 2 here makes most sense. So what we had, that 2 was already to the correct, the first term was already to the correct base. Then we had our times. Here we end up with 2 to the power of minus 1/4 x. Why minus? Because 2 was in the denominator, and that's what negative exponents do. They bring stuff from the denominator to numerator and back. Again, Duolingo first page is great for that. And my formulas too. Then 8 to the power of 1/4 turned to 2 to the power of, to which power? Type it. You already see that it's a fraction. More options? Well, 8 is 2 to the power of 3. So, perfect. We first started by just modifying 8, saying that 8 is 2 cubed, but then 8 itself was the power of 1/4. So we have to, account for that. So we have 3/4. Okay, great. Now, left hand, what we do, multiplication, requires us to sum up the exponents. So, minus 1/4. 1/4 x equals, well, let's do like already write it down in a nice form so we can solve quadratic equation. Equals to 0. Well, actually, even here you could guess. You could go, you could use Vietta's formula and go with the easiest. So the sum of two numbers is 1/4 and the product is minus 3/4. When you have fractions, always it's not the simplest way to do Vietta's theorem. But here it was okay, you could just guess that one of them is 1 and then the second one would automatically be minus 3/4. Or the way I did it, I did a discriminant and it was okay. The discriminant formula is also Duolingo first chapter, so you can check it. And what I got is x equals to 1 or x equals to minus 3/4. Well, there is actually another way to know the solution straight, but I really don't want to, bother you with the extra bunch of stuff, especially because this is not so important. If you just learn discriminant, you solve everything and anything. For the Duolingo first pages, now I'm referring everybody to Satchel because I already sent all the textbooks, so that's who you should ask for the whole textbook. I mean, the first pages, then I'm gonna refer to second, and then I'm gonna refer to the end of the textbook. So just distribute it among yourselves, okay? I believe you can do it. Cool. So thank you. And the very last one, the logarithms. So with the logarithms, we were also supposed to use some formulas. They're actually not useless, they're useful. You're gonna see more of letters. So now I'm showing you everything with numbers. Yeah, thank you very much. I'm showing you everything with numbers because it's easier and you can actually calculate and sum up. You will, in economic growth, mainly deal with that, and you'll have letters. 1 over alpha, natural logarithm of a plus blah blah blah. So the formulas will be useful, but the calculations, if you, I don't know, forgot how to deal with fractions, is not such a big deal, okay? So you still have to refresh everything, but don't get freaked out. 7, 14, and minus 3, logarithm of I, 7, square root 3, 21. Okay, nothing of this can be calculated. I mean, obviously, if you use calculator, you can get me straight the answer. But, well, you can go about it in a better manner. So we know that if we have this thing here, the coefficient, it is actually coming as a power of what we got here, right? Then with this logarithm we can do nothing. With this logarithm we can also fix the coefficient here. Okay, so what we get after all is logarithm 7 of 6, right? Then minus the same thing. Then minus logarithm 7, 21. 21 we got because it is power 1 over 3. That's what this weird cubic root means. Then we multiply it by 3, and then we get 1. Again, this is all this is coming from the formulas, well, not the formulas, but the rules of modifying logarithms that I have in my slides and that Dolink has in the first chapter. Okay, so here we can divide everything and get logarithm base 7. Of you don't want, right? Okay. We get logarithm base 7 of a fraction of 6, and here we have 14 times 21. It's just that we first divided 6 by 14, then we again divided the whole thing by 21, and that's what we got. And in the very end, you do the whole calculation, and you end up with logarithm of base 7 of minus 49. No, minus 1 over 49. And to which power should I raise 7 to get 1 over 49? You can type it. 49 is 7 squared, and since 49 is in the denominator, then the exponent has to be negative. Okay, so the answer is minus 2 here. Dun dun. That was the homework, and I'm gonna find something else for you for the just to train, you know, the exponents and maybe the quadratic equations, together with more exercises for the functions. So for today's topic, but I think for today that was okay. You should have been satisfied with all that. So I'm downloading this PDF straight, and then we start with another clean blank notebook. Okay, perfect. So now, oh, I hope I downloaded everything. Okay, if you don't mind me checking. Yes, everything. Okay, cool. So I'm gonna send you that, of course. This is the benefit of online, because when I'm writing on the whiteboard in a classroom, of course I'm not gonna send you the writings after the class. Okay, cool. So now what we have to do is close this, and I'm going to switch my share of the screen because it had just one window. Now we're gonna have 2 windows, like this and like this, and okay, please type plus in the conversation if you see on the left side my slides and on the right side my blank. Okay, perfect. Thank you. Great. So functions is something that is super crucial. Okay, so here it's way less of oh, I'm gonna just encourage you to think mathematically. Here is something that you will use all the time. So I'm going to try to refer to economics as much as possible here. And let's go. So we're gonna go on checking what's a function. We're gonna see some most common functions that you will see for sure. Their graphs, the very important notion of convexity concavity, what are inverse functions and how to calculate inverse of a function, and the last multivariable functions, that is something that you're gonna be dealing with all the time. So it's gonna be multivariable functions in all your models, because the more variables we have, for example, for utility function, the more realistic it is, because we know that in the real world consumers do not only consume apples and cars, they consume something else. So the more variables we add to the utility function, the more realistic it is, the better our model. So we're gonna deal with that, but we'll start right now with just one variable function, and we see what this is. So a function is a set of ordered pairs with a property that any x value uniquely determines a y value. And the red highlighting is important here. So just to give you an example of, well, what is not a function. Let's see. So just with this definition, without looking into more stuff, I can say that, for example, oh, sorry, y squared plus, no, yes, x squared equals 1, which is an equation of what? Tell me. Okay, yeah, circle. So that is something that you should know from high school or even from middle school. Yeah, it is. It can be a Pythagorean theorem, but if you want to plot it, right, it will be a circle. So if you don't know that this is a circle, no worries, just believe me, this is going to be a circle if you want to plot it. And in case of a circle, what do we have? Like, for example, let's take out this thing. I have to get out of the math mode. No, that's bad. I have a circle, right? And then I can do my, oh yeah, I can put my, yeah, you're right, Yuna, it should be equal to c squared, but what if c is equal to 1? Yeah, exactly. So it can be a particular case of that thing. Okay, now, well, actually on the whiteboard it's not like I'm drawing very faster, much faster, I mean. Okay, so let me zoom it a bit. If I say that the horizontal axis is x and the vertical axis is y, you can see that for 1x, like here, somewhere here, I have two possible y values. And that means that, this thingy is not a function. So this is just one example of what is not a function. Another example would be if I draw you something like, no, what did I do? No. Sorry. Okay. Hello. Okay. Goodbye. Cool. So if I draw you something like this, but like this. This is gonna be also not a function. So this beautiful thing here, it is not a function because to each x we have a lot of y's. That means that we cannot call this thing a function. Okay, that's important. Good. Now I can, no, I'm gonna leave it for now. Great, so then let's see. We have y, value of the function, dependent variable. So that's how we call this thing. Obviously, it's a letter that we choose. The most common is choose y as a dependent variable and x as independent variable, but we can even switch them, you know, it's just the matter of each example. So given I write it like that, so I set up a framework with y equals to certain function of x, y will be called value of the function or dependent variable. X will be called argument or independent variable. So this is just a vocabulary that I'm giving you here. Then d of y is going to be the domain of the function. What does it mean? It means that the set of all values that x can take. You can tell me, well, what can be the boundaries, for example, for x to take, well, x can take whatever it wants to take. Well, let's consider one example, just one. Sorry, I deleted it because otherwise it takes too much space. But you got it, circle is not a function. So for example, let's consider y equals to square root of x minus 4. Okay, so here the domain of this function is not all x's that we can think of. So in here, what do we have to ensure? We have to ensure that something that is yeah,